Well, good morning, everyone. I am so pleased and honored to be here. I have been very impressed over the years by the work of the Stegner Center, and so it's a great opportunity and a great honor to be part of the Stegner Center's symposium, 15th symposium. I'm also a devotee of Wallace Stegner, who was a professor at Stanford, where I am now, and also my favorite author in the world, so I'm doubly pleased to be part of this particular symposium. And I thank the directors and my good friend Bob Kiter especially for inviting me here. And I thank all of you for being up at 8 o'clock in the morning on a beautiful, beautiful day in Salt Lake City. So I'm going to talk today, I think about what we all, many of us anyway, see as the key challenge for the 21st century, this sustainability challenge. Now, there are lots of different definitions for sustainability. In the corporate sector, we think about the triple bottom line, we think about the 3 E's, economy, equity, and environment. Most of the definitions have the common thread of being concerned about the welfare of future generations, not just our own, being concerned about meeting the needs of people as well as the environment. So the definition that I use, and the National Academy of Sciences uses, and the Woods Institute for the Environment at Stanford uses, is simply this statement of goal. Figuring out how we can meet the needs of people today and in the future, our needs for food, energy, water, education, employment, and so on, while at the same time protecting and sustaining the life support systems of the planet, our atmosphere and water systems, our climate system, and the species and ecosystems on land and in the oceans that provide so many of the things that we rely on every day and that our future generations are going to need in order to have their needs met. It's very simple, very easy to state that goal, very challenging to tackle it. And I'm going to spend a little bit of time talking about why it is so challenging, and then that's the depressing part of the talk, and then I'm going to shift to some of the things that are going on, and I think as you'll see through the rest of the symposium, there are really exciting and very positive efforts. This can be a very positive topic. But why is it so challenging? Well, if you think on the meeting the needs side, the social side, it is true that a lot of things have gotten better around the world. More people have access to healthcare and education than ever before. And yet there are 1 billion adults, mostly women, who can't read. There are several billion people who don't have access to clean drinking water or to sanitation or to modern forms of energy or to shelter, and there's almost 1 billion people who go to bed hungry a lot of the time. There's a widening disparity between the world's richest and the world's poorest, and this is today with our 6.5+ billion people. And our population globally is still growing. Most demographers believe that our population, the world's population, will level off sometime in this century, towards the middle of the century, somewhere around 9 billion people. And that matters whether it's 9 or 10 or 8 billion people, but at least we're talking about a leveling off of the human population. That's the good news there. Nonetheless, we have to meet the needs of all of those additional people. Okay, so huge challenges on the meeting the needs side. We're not doing very well right now. We've got a lot of work to do. Same on the life support system side. And I'm going to spend a little more time on these because I'm a natural scientist and a lot of my career has been focused on some of these, not because they're more important than the human needs part, it's because I know more about them. So let me just talk briefly through some of them. Atmospheric change, yes, in many parts of the world things have gotten better in air pollution, for example, in urban air pollution. But many parts of the world are seeing the urban air pollution problem become region-wide tides of smog and air pollution. So we haven't solved that one. We are obviously changing the atmosphere in many other ways. We're increasing the concentrations of a number of gases, carbon dioxide, methane, and nitrous oxide, that are long-lived or longer-lived gases in the atmosphere. And they have lots of impacts on the planet on which we live. Carbon dioxide, for example, shown there at the top, increasing dramatically since the beginning of the Industrial Revolution. Today it is at a level that is unlike anything the planet has seen for at least the last 800,000 years, and probably a lot more. That matters because carbon dioxide, of course, is the base of the food chain. It's what photosynthetic organisms, plants on land and in the oceans, use to fix carbon and to build biomass that then the rest of us organisms on the planet consume. Some plants are doing really well with this extra carbon dioxide in the atmosphere that we're putting there, by the way, through fossil fuel burning and through land changes. Some plants do really well with that excess carbon, and they respond by growing more. Others don't respond very much. And that one of the things that means is that these ecosystems that we know and love, like that picture of the tropical forest in Costa Rica that I happen to love, are changing, are not going to be the same kinds of systems over time because of this differential response. In the oceans, it's even a bigger deal, though, because as atmospheric concentrations increase of carbon dioxide, it diffuses into the oceans. In fact, the oceans have taken up a lot of this extra carbon dioxide we've put into the atmosphere. But that's changing the carbonate chemistry of the oceans and making them more acidic. So this acidification of the oceans then makes it very difficult for organisms like the corals that have carbonate skeletons to build their own skeletons. So many of the ocean's ecosystems are imperiled simply because atmospheric concentrations of carbon dioxide are increasing so rapidly. So those are challenges, but the thing that we're focusing on probably most right now is that these gases are greenhouse gases. They have the ability to absorb heat, infrared radiation that's coming off the Earth's surface, leading to a warming of the lower atmosphere and the Earth's surface. And we would expect that as these greenhouse gases increase in the atmosphere, as we know they are, we would see a warming of the atmosphere and the planet, and indeed, we are. Now, this next slide, unfortunately, I've somehow lost my figure showing this trend in increasing temperatures. The trend is what's important here. You have to look over decades to see climate change. You can't look at what happens today versus last week or last year. But over decades, we see this increasing global average temperature. That is a global number, but the key here is that this isn't evenly distributed around the planet. Today, and again, for reasons physically that we understand pretty well, the high northern latitudes are where most of the warming is occurring. They're not just warming by a degree or so Fahrenheit, they're warming by 2, 3, 4, 5, 6 degrees Fahrenheit. So it's not equally distributed around the planet, and if you really want to see what's going on with climate change today you'd go to the Arctic. There's lots of other evidence, though, besides just temperature changes. Ocean temperatures are increasing. We know that sea level is rising, very good data on that. Know that sea ice is melting, good long-term trend data on that. Glaciers, continental, including mountain glaciers. Growing seasons in the United States have lengthened a couple of weeks. Bud break is earlier. That has some positives and some negatives. Forest fires are increasing in this part of the world, the western U.S. especially, related to temperature and drought. Snowpacks declining, pretty good data there, et cetera, et cetera. So there's a lot of pieces of evidence that tell us that we're in the midst of change. The question is, so what? Right now the answer, at least around here, is it's not a big deal. There are parts of the world that are having some challenges related to climate change, but the real question is, where are we going in the future with this if we continue to emit greenhouse gases from our activities? What will climate look like, and what are the consequences? And there's a lot of uncertainty. We don't know what all these things. But I point out here that this is a sustainability challenge, because it's not just an issue of energy and climate. It's an issue of what does that mean to food, to water, to the other things that people need and that our children and children's children are going to need in order to meet their needs. That's where there are real risks related to climate change. And I'll come back to climate and energy a little bit later briefly, just to think about it, the flip side of it, what to do about it. But we go back to our life support systems list, and there's a lot of other changes going on. We have, through our activities, changed more than half of the ice-free land surface of the planet. Can you believe that? We've changed it completely. Of course, we've changed it for things we need, agriculture, our cities, transportation systems, and so forth. But one of the consequences of that land use change is that we're driving species to extinction at rates much more rapid than the natural background rates of extinction. We're losing the kinds of services that ecosystems provide us, like water purification and so forth. Lots of other challenges going on. And so, this is an enormous challenge to meet that goal. The biggest problem with it is that we don't really know what to do. Humans have not had to do this before. We haven't had to, except maybe on some isolated islands, we haven't really had to figure out how to do both of these things at the same time. And to care about the well-being of people, all people, while at the same time protecting resources and the life support systems so future generations can have their needs met. And so I like to think about this as though we're in a transition. You know, we're not going to get there overnight. We don't know all the right things to do. We are in uncharted territory. And that means there's going to have to be a lot of trial and error, learning by doing, and we're going to have to move step by step towards this sustainability goal. And I think a lot of the talks that you'll hear in the symposium are examples of that. None of them have all the answers there, but that we're starting. And I think the good news is the world is starting. So if we don't exactly know what to do, it is true, though, that we have a pretty broad consensus around the world in at least what areas we should be focusing our attention. Going all the way back to the Brundtland Report, Our Common Future, to the Kofi Annan's Achievable Agenda from the World Summit on Sustainable Development in 2002. The one in the middle is one I was involved in of our National Academy of Sciences, but there are many, many more. And generally, we agree. We've got to get energy right. We've got to work on food and on living resources and biodiversity. We have to focus on water and sustainable cities and so forth. So we have a consensus around the world about what we should be working on. Given that, what's it going to take to actually make progress in this transition to sustainability? Well, I'm going to speak about this as an academic, as a university person, a little bit, but I'll expand it beyond because obviously this is not a job just for universities. I think some of the things that are required are new knowledge, new tools, new approaches to help decision makers who are trying to make decisions for sustainability. It's going to take linking the knowledge we already have and the knowledge we are developing through our research to action to make sure that it's useful and usable and used. And it's going to take educating leaders, including educating the public. Those are things that the universities of the world, the Stegner Center and others like it around the world are engaged in. But there's a bunch of other things that are needed, and this is not, property of the universities. This is all of us. We really need some inspiration here. We need the will to change, and we need leadership. And I'll come back to these at the end. So what I'd like to do is just use a couple of little stories to tell you about some of the research, I think, that is going on around the world, and some that I've been involved in directly, that illustrate, I think, this transition to sustainability and the things that we can do to help. I'm going to start with the energy-climate nexus, and let me remind you that I think this is not just the energy-climate nexus. This is the nexus between energy use, climate change, future food, future water, all the sustainability challenges. So energy, of course, is a critical human need, and we use a lot of it in just about everything we do in the developed and the developing countries of the world. Demand has skyrocketed as human population and development has occurred. This just goes to 2000 by, it'll be, it's already much greater than that. And most of the energy resources today, most of our energy needs are provided by coal, oil, and gas, the fossil fuels. And so there are sustainability challenges related to that. We worry about the end of oil. Are we going to run out? What about natural gas? I think it's probably true that while we're not going to run out of those, they're going to get harder to get and therefore more expensive. So there are sustainability issues related to that. When it comes to coal, we've got a lot of it. We can go a long, long time with coal. Maybe no sustainability challenges related to access, but most definitely, there are sustainability challenges related to the fact that the fossil fuels are a major source of pollution. And not just the most important source of the greenhouse gas carbon dioxide that's being emitted as we burn them, but also others. So what are we going to do? How are we going to meet the energy needs of people, now relying so heavily on fossil fuels, while at the same time reducing and sustaining the life support systems? There's a lot of things we can do. There's a large portfolio of actions that can be taken and research that needs to be done to help that. We can develop and use clean energy sources, reduce energy demand, increase the natural sinks of the uptake of carbon by other parts of the planet. And we can recognize that we are in the midst, we are committed to some climate change, and we better identify who is most vulnerable and help them adapt to the changes that are underway. And we need to do probably all of these things. But let me just pick a couple of examples. We talk about developing and using clean energy resources. I think Dan Cameron is going to talk tomorrow about this in detail, so I'll just be brief. There's lots of options out there. They're being developed, they're being tried. We're learning from what works and what doesn't work. But I think one of the most important things we've learned even in the last decade is that it's not just about technology. It's not just about the technology, it's about how we implement them. So take biofuels, for example. Yes, biotechnology is a big area of research, really exciting. But we also need to focus our efforts on understanding and avoiding unintended consequences with respect to competition for land, for agriculture, for conservation purposes, with water resources, with other pollutants, and with equity and poverty issues and trade and security and so on. So we need to have a more integrative way of looking at which energy alternatives we choose and where. And that's an area of research. Obviously, reduce energy demand. Many people would say this is the low-hanging fruit. It is the low-hanging fruit. We know what to do, but there's also some new opportunities to do it. In the building sector, that right now accounts for, in the United States, almost 40% of our energy use, close to 50% of our CO2 emissions, carbon dioxide emissions. A lot of research, including at our Precourt Institute for Energy at Stanford, is focused on how to manage energy efficiency, how to change, how to understand human behavior and what it takes to change, how to develop new institutions and policy frameworks that encourage it, how to develop the new technologies that make it useful. And at Stanford, I think we're walking the walk with energy efficiency in that almost all of our new buildings, as well as retrofits of old buildings, are focusing on much more efficient energy use, reducing, as in our new environment and energy building, reducing energy use more than 50% and potable water use more than 90%. So it's a way that we're walking the walk, I guess, as well as studying it. Let me jump down to identifying vulnerability, just because this is an area of my own interest. I'll just touch on it briefly and then move on to another example. There are a lot of people and places around the world that are not going to suffer harm from, at least near-term, climate change. Depends on how far this goes over the next century. But there are also people who will, and places that will. And part of the challenge is figuring out where and who they are, and then helping them to prepare for the climate change that we are already committed to. Because, by the way, the emissions of gases that we're putting in the atmosphere right now will result in the climate that we experience decades, 30, 40 years from now. So what do we do about that? Well, there's a lot of interesting research going on today, including this piece by David Labelle and others at Stanford, that seeks to identify, through the use of models, remote sensing, new metrics, who and where are most vulnerable. This is in the case of agriculture. They're looking at the most food insecure areas of the world. And then they're projecting future climate, a variety of climate scenarios, and connecting that with crop models of the most important crops in these different regions to understand how they might change. And I don't know if you can see, this area of South Africa is going to have huge problems according to this analysis, and parts of South Asia as well. So the answer then would be focus in the international agricultural development area, focus on those areas and help those countries and those regions develop alternative crops that will do better in the climate that's coming, or that may be coming. Okay, let me go into another area, and this is an area of my own research, a place that I've focused a lot of my own attention over the years, and I'm calling it the Food Ecosystem Nexus. But really, it's the food, ecosystem, climate, atmosphere, water nexus, once again. These things are all so connected, and I'll illustrate that briefly. So I'm going to talk about a place in Sonora, Mexico, called the Yaqui Valley. This area, shown in red here, is about 250,000 hectares of irrigated wheat. It's in the middle of the Sonoran Desert, but it's irrigated wheat. And it's bounded on the west by the Sea of Cortez, or the Gulf of California. This is one of the world's biodiversity hotspots. It is an area where every conservation organization in the world probably is working because of its very high biodiversity value. And then to the east are the Sierra Madres, also really important in terms of their very special ecosystems and their biodiversity. So this agricultural region is sitting right there where it's interacting with those others. This place is interesting because it is, it's really the home of the Green Revolution. Now, just, what's the Green Revolution? It's from the 50s through the end of the last century, a very major international focus on improving agricultural production, recognizing that human populations were growing and we needed to meet their needs. And we, the agricultural development community, were extremely successful in this. Food production increased at rates faster than population growth. So there's enough food for everybody. And they did that through the use of improved genetic materials, like improved varieties of wheat and corn and rice, and also through the use of other inputs like fertilizers, water through irrigation, and pesticides. Very successful. Well, this place in Mexico is the home of the Green Revolution for wheat. It's where Norman Borlaug, Nobel Prize winner Norman Borlaug, carried out the early trials that led to the development of improved wheat varieties, high-yielding wheat varieties that then were spread throughout the rest of the world. This place is also the home of one of the major international research organizations for agriculture. It's called CIMMYT, the International Maize and Wheat Research Institute. And one of the reasons that we worked there is because CIMMYT is a central player in this area, and they were a collaborator with us. So the Yaqui Valley, as sort of home of the Green Revolution, has been very successful in growing wheat. And the green line at the top there is wheat yields, in tons per hectare, the amount of grain that's produced per area of land, dramatically increasing over these Green Revolution decades from way less than 2 tons per hectare to now close to 6 tons per hectare. And it's been around 5 to 6 for the last decade or so. It has not continued increase after this final date. This is, you can say, why were they so successful? Look at it compared to other places. Well, I think one of the reasons they were successful is that they were right there in the heart of this research focused on improved varieties. So that's part of the answer. But part of the answer is also that they were heavily encouraged to use all of the inputs that they could possibly need. One of those inputs are fertilizers. Here's an example of nitrogen fertilizer being applied to irrigation water. When the Green Revolution years started in the Yaqui Valley, as you can see there, in 1956, most of the land a lot of the land didn't receive any kind of inputs for fertilizer. And the amounts that they were putting on the crop were way too low, even for the yields they were receiving then. But because of national subsidies of fertilizer, you can see that by 1997, by 1980, everybody was applying fertilizer. And they were applying it at rates, about 180 kilograms per hectare of nitrogen, or pounds per acre. About the right amount, at least that's what the agronomists would say, about the right amount. But you can also see from this slide that they continue to increase the amount of fertilizer they applied into the 90s, even into the late 1990s. And that increase, that delta between 81 and 97 is really excess nitrogen. And our studies showed, and I'm just abbreviating right now, what was probably 10 years of work in the field, showed that that extra nitrogen that they were applying, which they were, by the way, applying prior to the planting of the seeds, so well before there was any plants in the ground to take up all that fertilizer, was resulting in a number of environmental problems. One of them was very high emissions of nitrous oxide, one of those greenhouse gases that I showed in that first slide. Nitrous oxide is rapidly increasing in the atmosphere, and agriculture is the main reason that it is. It's a very effective greenhouse gas. So nitrous oxide, lots of it being emitted because of the way they were carrying out agriculture here. NOx, this is an air pollutant. It's the precursor to smog. And the NOx emitted from fertilized soils in the Yaqui Valley is driving air pollution problems in the small cities nearby. And also, although we didn't study this, being no doubt deposited into those natural ecosystems downwind, and we don't know what the effect would be. But a lot of the nitrogen that was applied beyond the needs of the plants was ending up leaching out of the soils or running off the soils into surface water systems that drain then into the Sea of Cortez. The Sea of Cortez, again, being a very important place in terms of the natural ecosystems there. So we studied what the consequences were of that, or at least began the studies of that. And what we found is that a lot of the nitrogen that is leaving the land system moves through the streams and canals into the estuaries of the Sea of Cortez. Some of it is emitted to the atmosphere during that. A lot of it then ends up in the open ocean of this sea and causes, what you can see here, are very intense algal blooms. The red color is, these are measured by satellite, by sea-whiffs sensors on satellites. You can see very large blooms of algae. We have videos of this basically over time that show these swirling across the Sea of Cortez into all of these areas over here where all of the reserves for biodiversity protection are located. So, again, we haven't done the next step of research to see whether that's really terrible or not too bad, or what the consequences are, but it's clear that what's happening on land is influencing what's happening in the ocean here. So that's just the short fertilizer story. And we'd like to not have those huge losses of fertilizer with all of those environmental impacts. I'll come back to what we can do about it. I wanted to just mention the water story here because it's also extremely interesting and a focus of another 10 years of research. They've been lucky in the 50 years of the Green Revolution here. They've had all the water they could possibly want. And it's ironic because they are in the middle of the Sonoran Desert, but they supply their irrigation water by very large reservoirs. And just out of luck, during this 50-year period, they didn't have the kind of drought that, if you look back over hundreds of years through paleo records, occur there all the time. Every 50 to 100 years, they get major droughts. Projections with climate change are that those droughts will increase, but they've always had big droughts, just not in the last 50 years of the Green Revolution. So the bottom line is they use a lot of water, they use it very inefficiently, and they have basically no rules in place, no models, no tools that would help water managers manage water sustainably in the face of drought. So they were lucky until the end of the 1990s when they experienced the same drought that southwestern United States did. And as you can see from this picture, they basically pumped their reservoirs completely dry. And they put themselves out of business for a while. And of course, it was huge disruption, very challenging times, very difficult for the people there. It did eventually start raining again, but in the midst of this very challenging time, some new rules were put in place, models. We were able to help develop models that water resources managers now use so that they never have to do this again. So our job then was to say, okay, all these things are going on. What would a transition to sustainability look like in the Yaqui Valley? Now, I could imagine all kinds of big ideas about how they could do agriculture in the future that are not at all connected to the way they do it today. But those are not realistic. So we tried to be realistic. What can they do to move year to year to still meet the needs, to still produce food, to still survive economically while reducing these negative consequences? What could they do in a transition? And we focused on fertilizer use and water use for the reasons I just explained with those earlier stories. And we found a number of good management practices, alternative cropping systems and so forth that would allow them to maintain or actually increase yields of the crops they're growing now, reduce the environmental negatives of agriculture, and actually save farmers money. And we found that, in asking that question, yeah, it's actually possible. We found, for example, in use of fertilizers that they could apply much less fertilizer, if they could apply it more carefully timed to crop requirements. It's kind of a no-brainer. that would dramatically reduce, by tenfold, reduce the losses of gases to the atmosphere or to water systems. And it would maintain yields, and in some cases actually improve grain quality, and save the farmers money. We calculated between 12 and 18% of after-tax profits could be saved by changing to these new options. So win-wins are possible. You know, we thought this is great. We did on-farm trials. We did workshops with farmers. Some of the most innovative farmers picked this up, and they were doing it in their own fields. And we thought, wow, you know, we've helped. You know, there's a change undergoing in this region. And then we went back and surveyed and found out that, look at 2002, they're applying more fertilizer. So the win-wins, economic win-wins, weren't catching on. So why was that? Well, we had to step back then and say, okay, we missed something here. Let's try to understand why farmers are not interested in adopting these new options that are win-wins for the environment and for their economics. Well, first of all, we found that there's real risk aversion. Decision makers are risk averse generally, and the farmers here really were. They were uncertain about how much nitrogen was available in their soil, so they thought they could just put as much on and then they wouldn't have to worry about that uncertainty. They also were worried about variations in weather and climate year to year. You know, if it was going to be a really good year this year, so if so, they wanted to make sure they had enough fertilizer on for the best yields that they've seen in, you know, decades or ever. So they were throwing a lot of fertilizer on because of those uncertainties, but they were also throwing a lot of fertilizer on because credit unions were telling them to, in order to get credit. And so we realized we really missed something here in our understanding of decision making. We went back and started analyzing the decision-making system, or the knowledge system of this valley. This is what we thought when we started our research, that here we are in universities working with the very trusted, very credible international and national agricultural research communities. They have close connections with the most innovative of the farmers, and that we could make our transfer, in a sense, of this knowledge by working with these three players, our international agricultural agronomists and farmers. It turns out when we actually evaluated carefully what this knowledge system looks like, it looks like that. There are many more players. Lots going on here. I will point out that the Secretary of Natural Resources and the Secretary of Health are not linked at all. You know, you would think they'd be part of it, but they have nothing to say about what happens in this region. But who really has something to say are indeed those credit unions. Credit unions are farmer associations. The farmers belong to them. They trust them. They get a lot from them. They get advice. They get access to credit so that they can get their seeds. They get access to credit so they can get their fertilizers. And the credit unions were basically saying, if you want that access to credit, you have to put on a lot of fertilizer. Of course, there were a double, benefit for them, because they were getting the interest on the loans for the fertilizer, but also because they weren't taking any risks either. They wanted to get the highest yields possible. So one of the ways that we decided to try to solve this, help solve this problem, was to develop more real-time information, other kinds of information that would help farmers decide what to do in real time, rather than having to guess what they need at any given time. And one of the things that we've developed and used in this area is a handheld radiometer that basically tells the farmers how much nitrogen is in their crop and when the crop starts really needing more. So they know when and how much fertilizer to apply, rather than having to throw it all on at the beginning. And there are other kinds of tools like that are being developed or have been developed to help them get a better idea of what they need in any given time, in any given field, and in any given year or season. But the key here was that we realized we needed to work with the credit unions if we wanted this to be useful, because the credit unions were holding the strings. So as it ended up, the credit unions were engaged in this because the innovative farmers wanted them to be, and they ended up buying these instruments, which cost about $20,000 each, for their farmers, for their association. And now the farmers have access to it. And last data show that this is really being used widely in the valley. Most of the farmers of the valley use it. So the interesting thing about that story, and I'm almost done here, we can have some questions. The interesting thing about that story, though, is that it's not about just building new knowledge. It's about making sure that that knowledge is actually linked to decision makers. And you don't do that, you don't assume that that's a pipe where you put in knowledge on one end, new information, and when it comes out the other end, it's just used by decision makers. My social scientist colleagues would tell me they've known that for a long time. It doesn't work that way. We need to engage with decision makers in making sure that what we're doing is actually helping them solve the problems that they see as well as that we see. And that's a challenging thing for academic institutions to do. And at some places around the country, including at Stanford, we've actually put things in place to facilitate that. At Stanford, the Woods Institute for the Environment, who Buzz Thompson, who's here, is the director of, is there in part to facilitate that, to help us make sure that we are engaged in a discussion with decision makers, that we're asking the right questions from their perspective as well as from our scientific perspective, and that the results of the research that we're doing for the transition to sustainability is actually useful and used. Now, one last word about educating leaders. This is, I think, something that we in academic institutions are all about. We care about that. We always have, and we always will. But I think in the sustainability realm, it's going to take people who understand how integrated these challenges are. It's going to take people who, while they have their own deep knowledge, understand the broader context, who can be in a conversation, work with, or even do interdisciplinary, multidisciplinary work, because these kinds of problems just can't be solved by one discipline working alone. So a challenge for universities is to figure out how to provide that kind of training that leaders in the 21st century are going to need in order to grapple with the really, really complex challenges of sustainability. And that's a conversation that many people in this room can have. So universities can play a role. We like to think that we are. We all need to do more. But as I started out with, this is not just for us. This is something that everyone has to engage in our everyday lives, in the way we build or remodel our houses, and the way how we use energy and water, and how we think about the future. I think that this willingness to change is one of the biggest challenges. There needs to be a lot more research on what it takes for people to be satisfied and satiated with what they have rather than what they want. What it takes for people to decide to change and to make the changes happen. How to walk the walk that we also talk. And ultimately, this is going to happen through leadership. And we have a lot of that leadership already. Things are happening. Thankfully, many corporations, have taken that leadership already in their own corporate activities and in their philanthropy. They've made a difference in that. We have many citizen groups doing the same. We have many cities and states in this country and nations around the world actively engaged in a transition to sustainability, purposefully engaged in it. So there's lots of models out there to look at. We need, and I think in this country, our federal government to provide leadership for this, and I'm beginning to see some pieces of that happening. But even without that, we're engaged. The question now for us, I think, is how to move this transition to sustainability much, much more rapidly than it's going right now. How to push this along so that we move further along the transition, we get closer to that goal, and we ultimately improve the well-being of people in our generation, but also make sure that our children and grandchildren have what they need in order to live well on the planet.